Good morning, chemistry students. Here is your Chapter 6, Day 1 notes. We're going to do all of Section 6.1, Introduction to Chemical Bonding. A lot of this is going to be a review because we're, again, going to kind of just start with an overview of ionic compounds and an overview of molecular compounds, which we've already talked about throughout Chapter 15 and throughout Chapter 16. Before we start to talk about that, I do want to talk about polyatomic ions that you have to memorize. So, I don't ask you to memorize much. I don't ask you to memorize the periodic table. That is goofy and ridiculous to me because every chemist always has access to a periodic table to use, okay? So I don't do that. I'm going to ask you to memorize these 10 things. This is the only thing I'm going to ask you to memorize, but I'm going to ask you to know it for Chemistry 1A and Chemistry 1B. These are polyatomic ions, and you saw these the other day on your ChemQuest. Okay? I chose these 10 because these are the 10 that we use a lot in chemistry. And I've had many students who've gone on to college chemistry who've come back and thanked me that they had memorized these because these were also the ones that are used a lot at the college level. So these are polyatomic ions. We will occasionally have polyatomic ion quizzes. And on a polyatomic ion quiz, I may ask you one of two things. So I may give you the name. So for example, I might say nitrate and ask you what its symbol and charge is, in which case you'd have to answer NO3 -1. I might give you the symbol and charge and ask you to tell me the name, in which case you would say it's carbonate. So you need to know these both directions. You need to know both their names and their symbols and charges. My suggestion is that you make yourself some flashcards or you make yourself a Quizlet deck and you work at memorizing these. So we have nitrate, hydroxide, sulfate, carbonate, chromate, phosphate, ammonium, hydrogen carbonate, permanganate, and chlorate. And you see those symbols and charges. On that polyatomic ion sheet, it also says that you're expected to know all the charges of the main group or group A atoms when they form ions. So what I'm talking about here are, again, the tall columns on the periodic table. Now, again, I don't expect you to be able to do this without a periodic table, but with. So what I'm getting at there is, remember this group 1A, okay, remember that means that they always have a charge of +1. Because they have one valence electron and it's easier to lose that one than it is to gain 7. Group 2A always has a charge of +2 because they have 2 valence electrons, and again it's easier to lose those 2 than it is to gain 6. Group 3A always have a charge of +3 because again they have 3 valence electrons and it's easier to lose those 3 than it is to gain 5. Typically, group 4A doesn't form ionic compounds. Group 5A, okay, remember they have a charge of -3 because they have 5 valence electrons, and it's easier to gain 3 than it is to lose 5. Group 6A, a charge of -2. Again, that's because they have 6 valence electrons, and it's easier to gain 2 than it is to lose 6. And finally, group 7A has a charge of -1 because, again, they have 7 valence electrons and it's easier to gain 1 than it is to lose those 7. So that's what I mean by knowing the charge of the ions in the main group or group A elements. Okay, I'm talking about the tall columns on the periodic table and knowing what charge those columns have. The last part of that polyatomic ions to memorize paper is that you have to know Hofbrinkel, which are these diatomic molecules. So there are 7 of them. That'll always be a question on a polyatomic ion quiz. And you have kind of 2 choices of how to write them. You can write them diatomically as H2, O2, Br2, F2, I2, N2, Cl2. The order that you write them in doesn't matter as long as you have all 7 of them. Your other option is that you can write them by their names. So you can say that they are hydrogen, oxygen, bromine, fluorine, iodine, nitrogen, and chlorine. Now, you don't get to use a periodic table on your polyatomic ion quizzes when you take them in class and such. So you do need to know what these 6 or 7 elements are. So those are your polyatomic ions, and kind of to get you ready in the event that you're going to have a polyatomic ion quiz. Again, we are kind of going to get an overview. A lot of this is going to be review because we've already talked about it before. So this first section is just an introduction to chemical bonding. And we're going to start by talking about molecules and molecular compounds. And again, keep in mind that elements are the building blocks of all living and non-living things. And so basically what I'm saying is everything as you look around you in the world is made of elements. And there are lots and lots and lots of different kinds of things as you look around you. So these elements make up millions of different compounds. And if these, right, on our periodic table, like there's 109 to 112 different elements depending on your periodic table. If these 109 to 112 different elements can make up millions of different compounds, we have to have a way to name them. So there must be a way to name these different compounds. Now, kind of remember that our noble gas elements tend to exist alone. What I mean by that is the noble gases, because they have those very stable electron configurations, they don't tend to get involved in forming chemical bonds and in chemical reactions. They tend to exist all by themselves alone. Because of that, the noble gases typically are described as being monatomic. And we've seen this word before. Remember, monatomic means that they consist of a single atom. So what is a molecule? Remember, our molecule is defined as our smallest electrically neutral unit of a substance that still has all the properties of the substance. So remember, we talked about this as if we have a big, huge chunk of molecular compound. When we talk about a molecule, that's our smallest piece that we could chop that big chunk up into, and it still would have all the properties of that original big chunk, okay? So this is that smallest piece that still has all the properties of the substance. In a molecule, 2 or more atoms, okay, are acting as a unit. So in a molecule, you have 2 or more atoms that act as a unit. Some examples of molecule are oxygen gas that you breathe and require for life, and ozone gas, which is O3. So these are both examples of molecules. Again, a molecule is specific to a molecular compound. So a molecular compound is defined as a compound composed of or made of molecules. Now, some of the properties about molecular compounds are that molecular compounds have a low melting point, and boiling point. And again, we talked about this the other day. Okay, and because molecular compounds have low melting points and low boiling points, molecular compounds are often a gas or liquid at room temperature. So if you have to guess about whether something's a molecular compound without necessarily knowing its formula, if that substance is a gas or a liquid at room temperature, the best guess would be that it's a molecular compound. For us, molecular compounds are going to be usually made of 2 nonmetals. That's how you are going to know that a substance is a molecular compound, is you're going to look for it to be made of 2 nonmetals. And know that in molecular compounds, the properties are different when the atoms combine in different ratios. Some examples of that, okay, H2O versus H2O2. Okay, anybody know what H2O2 is? That is hydrogen peroxide. So these are the same two elements, right? Both hydrogen and oxygen, but they're combining in different ratios. In water, it's 2 hydrogens to 1 oxygen. And in hydrogen peroxide, it's a 1-to-1 ratio, right? 1 hydrogen to 1 oxygen. So those do result in very, very different properties for these compounds, right? On a hot summer day, okay, you do not want to go and get a refreshing glass of hydrogen peroxide. If you do, you're going to get sick. Okay, it's going to make you vomit. Might even make you more sick than that. Okay? Versus on a nice hot day in the summer, a nice refreshing glass of water is fantastic. Okay? So again, this is an example of these atoms combining in different ratios and having very different properties. Another one I want to talk about is CO versus CO2. This is kind of my public service announcement as we transition into the colder time of the year, right? So CO2, carbon dioxide, right? Everyone exhales carbon dioxide. It's in the room right now. It's all around us. Okay? Odorless, colorless gas, harmless. CO is carbon monoxide. Now, maybe you know something about carbon monoxide. Carbon monoxide is also an odorless and colorless gas, but it can kill you. So, why the public service announcement? Because carbon monoxide comes from burning fossil fuels. So, you produce carbon monoxide when you burn gas in your automobile engine. That's why, if you happen to be lucky enough to get to park in a garage, if you warm up your car before you head to school, you have to open up your garage door because you don't want that carbon monoxide to build up inside of your garage. Okay? But that's not the only spot you use fossil fuels. Probably most all of you burn some fossil fuels somewhere in your home. You probably use fossil fuels, either natural gas or an LP, a liquefied gas, in your kind of, oftentimes we call them pigs that are outside our houses. Okay? That's a fossil fuel. And when you burn that, one of the things that's produced is carbon monoxide, which is why your furnace, your hot water heater, they're vented to the outside of your house so that carbon monoxide doesn't build up inside your house. It exits your house and goes outside. Okay? So the public service announcement is you should have, if you have a natural gas, if you burn natural gas for any of your appliances, or you burn LP gas for any of your appliances, there should be a carbon monoxide detector in your home, preferably somewhere fairly close to those devices that use that natural gas or LP gas. Because if carbon monoxide builds up in your home, it can kill you. It is deadly. Okay? This is also an important thing to keep in mind moving forward as you become adults and start your own families at some point in the future and buy a home or rent a home. Okay? You want to have carbon monoxide detectors because the unfortunate thing about carbon monoxide is it's more deadly the smaller your body mass is. So oftentimes, kind of the stories you might hear in the winter about carbon monoxide poisoning are that infants or toddlers have passed away, they've been killed because of carbon monoxide poisoning. So it affects infants and small children before it affects adults. For adults, oftentimes, and the reason it's dangerous is that it gives you a headache, it makes you sleepy. So you kind of get a headache, right? And you're like, oh, I have a headache. I'm going to go try to go to sleep to kind of get rid of this headache. And it turns out you never wake up in the morning because you've died of carbon monoxide poisoning. So it's symptoms can be misinterpreted as just having a regular old headache. So it's very dangerous. Your pets also can suffer from carbon monoxide poisoning, and your pets are typically smaller than you are. So if your pet starts to act in a weird way, sometimes it can be a clue that there might be a problem and you might have carbon monoxide building up in your home. So this is a good time to kind of check that you do have carbon monoxide detectors in your house and that their batteries are working, because we're coming up on the winter when our houses are all closed up because it's cold outside and we're burning fossil fuels frequently to heat our home. So another example of different ratios of the same atoms having very different properties as compounds. So transitioning then to ions and ionic compounds. Remember that we've defined ions already. They are atoms or groups of atoms that have a positive or negative charge, right? We just talked at the start of these notes about those polyatomic ions that I would like you to memorize. Those are groups of atoms that have a positive or negative charge. Remember, our ions form by losing or gaining electrons. Now again, remember, we would have really kind of three options here for how we form ions. We could gain or lose neutrons. We could gain or lose protons. We could gain or lose electrons. So why is it that we're not talking about forming ions by gaining or losing neutrons? Well, sort of two reasons, right? First reason, neutrons are neutral. They don't have a charge. So gaining or losing them wouldn't cause us to form ions. Second reason, right? You should know, what do we call atoms that have different numbers of neutrons in them? They're isotopes. We've already talked about atoms that have different numbers of neutrons. So we can't talk about forming ions by gaining or losing neutrons. So what about protons? Right? Protons have a positive charge. So if we gained protons, we could get a positive charge. And if we lost protons, we could get a negative charge. So why aren't we talking about gaining or losing protons? Remember, that's because carbon has 6 protons, and that makes it carbon. If I took carbon and gave it 7 protons, it wouldn't be carbon anymore. It would be nitrogen. Remember, the number of protons in an atom is what makes an atom a particular atom, right? That's its atomic number. And if I change my atomic number, if I change the number of protons in an atom, it's not the same atom anymore. It's a different atom. And when I form ions, I don't want to talk about totally changing the atom. I just want to talk about taking that atom and giving it a charge. So protons, not an option. So my only way to form ions is by gaining or losing electrons. Remember that when we call something an atom, that means it is neutral. And it's neutral because the number of positively charged protons is equal to the number of negatively charged electrons. So how do we form a sodium ion? Well, sodium has 11 protons, and as a neutral atom, it has 11 electrons. When it forms an ion, remember that sodium has 1 valence electron, so it can either lose 1 or gain 7. Remember, it's always going to do what's easiest. It's going to lose 1, so it's going to become Na with a +1 charge, which means it has 11 protons and only 10 electrons. Remember, it's gotten 10 electrons just like neon, which is a noble gas. So, ions are generic. I can call a positively charged ion an ion. I can call a negatively charged ion an ion. But remember, we do have some more specific language. We have what's called a cation. A cation is defined as any atom or group of atoms that has a positive charge. Okay, so remember, cation is specifically an ion that has a positive charge. Remember, the types of elements that typically form cations are the metals. So these are typically metallic elements. The metals have lost electrons, therefore they have less electrons than protons. Therefore, they have a positive charge. With cations, the charge is written as a positive followed by a number as a superscript, a pi. In terms of naming a cation, remember we've touched on this a little bit. It is the same as the element plus the word ion. And keep in mind that the property of a cation is different from the neutral atom. So what we want to look at here is we're going to look at an example. For this example, I want you to determine the number of protons, the number of electrons, and the name. And this is the last thing that needs to fit before anion. So I have Li plus, Al plus 3, and Mg 2 plus. So go ahead and pause your video if you need a little bit of time and your periodic table. Okay. But go ahead and use your periodic table and figure this out. So for lithium, lithium is atomic number 3, which means it has 3 protons. Now lithium has a +1 charge. That means it has lost 1 electron, so it only has 2 electrons. And its name as an ion would be lithium ion. For Al plus 3, this is aluminum, and it has 13 protons because its atomic number is 13. It has a +3 charge, which means it has lost 3 of its protons. So it has 10 electrons, just like neon, and its name is aluminum ion. Our third one here, Mg. Mg has an atomic number of 12, so that means it has 12 protons. It has a +2 charge, which means it has lost 2 of its electrons, so it now only has 10, just like neon. And its name is magnesium ion. So pretty much we want to do the same thing that we just did for cations for anions. So anions are atoms or groups of atoms that have a negative charge Remember, anions typically are going to be the nonmetals, so it's non-metallic elements. They gain electrons, therefore they have more electrons than protons. Therefore, they have a negative charge. Okay. Again, their charge is written as a negative followed by a number as a superscript. And again, we have talked a little bit about how we name them. We saw this on one of our chem quests. To name anions, it is the element name minus its ending, and then you add "-ide". And just like the cations, the properties of an anion are different from their neutral atoms. So again, we want to look at some examples here. And for these examples, again, I want to know the number of protons, the number of electrons, and its name as an ion. Cl negative, O negative 2, Br negative 1. So again, if you need a little bit more time, you can pause the video so that you can use your periodic table to figure this out. So I look up Cl on my periodic table, and it's chlorine, and it has an atomic number of 17, so it has 17 protons. Now, it has a negative 1 charge, which means it has gained 1 electron, so it now has 18 electrons, just like argon. And its name is going to be chloride. Oxygen has an atomic number of 8, so it has 8 protons. It has gained 2 electrons, that's why it has a negative 2 charge, so it's going to have 10 electrons, just like neon, and its name is oxide. For bromine, bromine is atomic number 35, which means it has 35 protons. It has a negative 1 charge, which means it's gained 1 electron, so now it has 36 like krypton. And it's going to change from being bromine to being bromide. So now that we know what, or have reviewed really, what cations and anions are, we can talk about what an ionic compound is. An ionic compound is a compound composed of or made of cations and anions. Most times your ionic compounds, most times your ionic compounds are going to be usually made of a metal cation and a non-metal anion. And remember, on our chem quest, there were sort of 2 rules that we had to follow. One of the rules was that our total positive charge equals our total negative charge. Therefore, we are electrically neutral. Okay. And remember, we also always write the positive ion first. So if we kind of look at lithium ion and fluorine ion, they're going to combine in a 1-to-1 ratio so that they overall have no charge as LiF. When we look at a sodium ion and an oxide ion, to combine so that we overall have no charge, we're going to need 2 sodium ions and just 1 oxide, so that one chemical formula will be Na2O. Ionic compounds are usually a solid crystal at room temperature with a high melting point. And to name ionic compounds, you are just going to combine the name of the cation and the anion, dropping the word ion. So for example, right, LiF is lithium ion and fluoride, so its name is lithium fluoride. Na2O is sodium ion and oxide, so its name is sodium oxide. So the last thing we have is this table. And we talk here about a representative unit. And remember, when we're talking about representative unit, we're talking about the smallest piece that still has all the properties. Okay, so we're talking about if we have a big chunk of something, what's the smallest piece we can chop it up into and it still has all those properties of that original big piece. So you see, we're going to talk about molecular compounds in our first column and ionic compounds in our second column. So let's talk about molecular compounds first, right? We've talked about that representative unit. That representative unit, or that smallest piece of a molecular compound, is called a molecule. And again, we're going to refer to molecule quite often, so we sort of want an abbreviation, so it's MOLC. Molecular compounds are non-metallic, so we're going to say that they're made of 2 nonmetals. And again, that's how you're going to know that a substance is a molecular compound. Their physical state can be a solid, liquid, or gas, but normally remember that they're going to be usually a liquid or a gas at room temperature. And their melting points are low. By contrast, when we talk about ionic compounds, the smallest piece of an ionic compound that still has all the properties of an ionic compound, that's called a formula unit. And remember, that's typically everyone's favorite abbreviation because it's an FU. We're going to know when a compound is an ionic compound because it's made of a metal and a nonmetal, or it has a polyatomic ion in it. And we're going to talk about polyatomic ions more a little later in this chapter. Remember, ionic compounds typically are going to be a solid at room temperature. Oftentimes they're a solid crystal. And ionic compounds have a high melting point. So that brings us to the end of our first section of Chapter 6. Your homework assignment is on page 137, questions 3 through 9. Have a great day. I'll talk to you tomorrow.